Today we're going to talk about lockup. Why is lockup confusing? Why is it your friend? And I'll explain it's actually very simple and very beneficial, but it blows my mind that we don't know anything about it really. So let's talk about lockup. Now, the best way I can explain lockup to you in a very short description instance is a lockup torque converter is a type of torque converter with a clutch. Okay, it's that simple. And what this clutch does is the engagement causes the engine to lock the transmission input shaft directly to the engine, thereby leading to a true 1-to-1 ratio rather than the 1-to-1 ratio with slippage in third, because third is not mechanically locked. It's still being hydro locked by the fluid coupling with the fluid. Fluid being the coupling thus generates excessive heat, and that's also going to come from your stall speed. So if you guys are watching this video and want to get really in depth, go watch my stall speed video. That's going to cover this a little bit more, and maybe that video will make more sense as well. So lockup, that being said, lockup is a mechanical hydraulic function of reducing the slippage in the converter from fluid to essentially zero, and reducing the heat generated by the fluid lock of the converter. When you're churning fluid that fast, you're building friction. Friction equals heat. It's a very simple, common equation. Instead of the fluid as the coupling, using the turbine speed, the converter clutch is applied to the backing plate. As you can see there's a stamped steel backing, and there's a gigantic single disc OEM converter clutch. It is applied to the backing plate, linking the engine directly to the transmission's input shaft, reducing stress and slippage on the converter, and aiding in fuel economy, cooling, because when you have the lockup valve stroked in an overdrive transmission, the cooling circuit opens up so much to effectively cool the transmission right down. There's no stress on the converter itself because it's mechanically locked. That fluid can flow as it needs to and really super cool the transmission. So, and on top of that, you may even get better ETs on the track, the drag strip, just by having something like a triple disc converter, because more area, more clutches, 3 clutches equals more holding power, and you can lock it up at wide open throttle, unlike a single disc, which you can't do any of those things. If you have a triple disc, it may improve your ETs, because if you're locking it up at the bottom of third, top of third, or even the bottom of fourth, depending on your gearing and the amount of room of track you have, you might even shave off a whole second because you are mechanically locked, and that is only going to be as good as your motor is. Okay? The only other thing you might need to consider is your final drive ratio, which not a lot of us think about, but your final drive ratio in lockup will depend on a lot of your rear gearing and your tire size. And we'll talk about this in a different video, but a quick equation, sample one would be engine in lockup is 3,000 RPM or so, okay? So in lockup, we're seeing 3,000 RPM. Fourth gear in the 4L60, which is the subject today, is 70-to-1. And a true lockup is 1-to-1, okay? We're gonna say we have a 355 ring gear and the average 26-inch tire. And when you do the math on that, that overall ratio is gonna be 2.5-to-1 at a speed of about 90, 95 miles an hour, probably somewhere in the middle of that. That's off the top of my head. That is a sample equation, and we'll learn how to do that in a ratio video. But as you can see, that is essentially what the end-all be-all ratio in lockup would be. There are 3 major players in the lockup function of the 4L60E: the TCC regulator valve and solenoid, the TCC clutch valve and solenoid, and the converter itself. Now, the TCC regulator valve is a valve in the valve body that regulates the fluid sent to the apply circuit for the converter. The solenoid is called PWM, which is just pulse width modulation. And that will actively regulate the pressure seen on the backside of the regulator apply valve, which will regulate the pressure fed into the converter through the converter clutch apply circuit. This valve, by nature, PWM pulse width, it strokes often and rapidly. That is a bad thing. GM knows this, and any aftermarket transmission rebuilder, or even an OEM rebuilder anymore, will not let that happen. So mechanically, we limit that valve. It cannot stroke rapidly, wearing out the bore and causing a leak and a failure. When you have tuning software or buying an aftermarket transmission, you may want to program into your stock PCM or your standalone computer on or off instead of PWM, which is pulse width. Now, back to that diagram. This leakage, like I said, makes its way around the valve to an exhaust path, and the converter apply oil flowing through a very small orifice to stroke it will not meet the requirements for that valve to overcome the spring pressure, and you will not have lockup. The converter clutch valve in the pump is controlled by an on and off solenoid. This solenoid controls the direction of the valve stroke and nothing more. When on, the valve moves in, and when off, the spring pushes the valve back. When off, the regulated apply oil gets trapped between the two lands of the valve and just sits idle. We also call that signal fluid. And when on, the regulated apply oil is then allowed to flow to the converter, applying the TCC, or the lockup clutch. Then you have the converter itself. Normally the piston for the TCC, as you can see there, has pressure on the front, on the engine side, and is pushed when the clutches are off. When the TCC is engaged, the fluid on the front side is released and the opposite side is charged, and the piston pushes towards the engine, which mates the lockup clutch to that backing of the converter, and you have lockup. That's short, sweet, to the point. Some of the common failure points in lockup, and the reason why you wouldn't have lockup or it fails down the road, is actually very simple, because you're not going to be looking at a ton of things. One may surprise you. The TCC regulator valve gets worn out and leaks. That's more or less a build fault. The solenoid itself that plugs into the pump stops working, or it doesn't have 12 volts. Very easy to check. Pop the pan off, get your ohm meter out, check the voltage, see if it works. It could be stuck on and stuck off and have voltage. There are ways to test that. If it's stuck on, your vehicle will probably stall out as soon as you engage it in gear. And that's due to the converter itself being linked to the engine and it not being able to appropriately idle. Here's the one that shocks everybody. Your brake switch is either misadjusted or a complete piece of shit. The brake switch is the switch that actually will shut lockup off to keep your vehicle from stalling. So that is something to check as well. And lastly, the converter itself. Probably the most common cause to a non-lockup issue, other than the TCC solenoid. Solenoids just go bad, it happens. Converter, it's always going to be a build fault typically. The transmission doesn't really have too much input into how this thing operates because it has no brain. It has a simple piston, it's going to go on or off, and when you build a converter, you have things you have to take into account for, especially clearance when you sandwich all those pieces I just showed you together. We can look at that again. And all those pieces need to be sandwiched within a few thousandths, and that measurement is so exact. If it's off, your converter is probably going to fail, regardless of what the transmission does or how well it's built. So I'd like everybody to know it's not always the transmission's fault. A lot of the input into a transmission comes from your vehicle and the components provided, because in short, the transmission is stupid. It doesn't know what to do. Just by talking about that one solenoid. It's a magnetic ball with a coil, and it gets 12 volts or ground, and it's on or off. And that's every solenoid in the 4L60. So, going back on the converter and wrapping up the video, it could be the converter itself, and it's usually told by building excessive heat or a few codes like the P1870 code that everybody, I'm sure, has run into at some point in their lives. It blows my mind when people will reuse a converter not knowing its condition, or when something just had a failure and they'll reuse it anyway. The converter is a very important piece. It needs to be function properly, and you have a clutch. Your clutch can be compared to the 3/4 in your transmission or the main bearings or your cam bearings. Don't look at your cam bearings or they'll be bad. And some people really do reuse them, but why would you reuse something when clearly it's been worn? And then you would reuse a converter. It makes no sense to me. It's kind of like servicing the transmission. People will change the oil, but not the filter. Would you do that with your engine? Kind of asinine. Anyway, that's the gist of Lockup, and that's what it does. So thank you for watching. Please like and subscribe, and Lockup is your friend. Don't write it off yet. Give it a shot. It'll probably improve your ETs. Thank you for watching.